Okay, welcome back to our video lectures, and I personally welcome all the students to our module 3. Okay, if I tell about this module basically deals with the alloy and its accessory topics. Okay, so in this video we will not in this video, in this module we will see about the various phase diagrams. Okay, alloys and their various classifications of alloys and various phase diagrams to represent the effect of the temperature and concentration in as well as the pressure in obtaining various alloys, then its fatigue strengths, creep, and all such things. Okay, so it's a very important module as far as this material science is concerned. Okay, to begin with, we will see the alloy. Okay, alloy is defined as, or it is a combination of metals, or like metals, two or more metals combined together with another elements. Okay, like we can mix two metals, we will get an alloy, or else like we can just add some elements in particular so that its properties will improve, and we can call that resultant mixture as an alloy. Okay, so this alloy is a mixture of two or more elements in a solid solution. Okay, it's a solid solution. We can call alloy as a solid solution in which the major component will be a metal. Okay, so you can either add two or more metals, or like you can add some element, and it's not necessary that it should be a metal. Okay, let us take some examples and we can see in more detail how an alloy look like. Okay, so this is a particularly one kind of thing. Like this is iron, and when the carbon is mixed at various proportions, we will get an alloy known as steel. You all know the steel, which all applications we use the steel, why we are using the steel. Okay, so how this will getting benefited, how or why we need alloy. Okay, by adding another element into a metal, the difference in the size of the atoms create internal stress in the lattice of the metallic crystals. We all know how the lattice arrangements are there for a pure metal, or for a pure crystalline structures. So if we remove one element or one particular atom, and if we replace it with some foreign atom, so what will happen is that some critical internal stresses will be developed there. Okay, so that critical stresses, it can be either due to some compression, because the new material or new atom is of some large size than the basic atoms. So it will sometimes, if it in such cases, it will induce some compressive stress. If the atomic size is smaller than the original atom, so it will induce a tensile stresses. So such internal stresses will be developed within the lattice structure, and these stresses are often responsible for the enhancement of the properties. Okay, so this is very important sentence. You need to keep this thing in your mind, and you need to write this one, and you need to understand the concept. Okay, so this is how the alloy differ from other pure metals. Okay, so another concept you need to understand is that the electrical and thermal conductivity, or the electrical and thermal properties, will not be enhanced by an alloy. Okay, or in other words, the electrical and thermal conductivity of alloy is usually lower than that of pure metals. We cannot say it's better than the metals, pure metals. Okay, Whereas the physical properties such as density, reactivity, the Young's modulus may not differ much. There won't be much difference for these physical properties. So what is the benefit of adding these foreign particles or making this as alloy? The engineering properties such as tensile strength, ductility, shear strength, okay, such kind of properties will greatly differ. Okay. So by adding these alloys or adding the elements, we know that the things like or the atoms will move to some spaces and some internal stresses will be developed, and these stresses will improve its engineering properties such as tensile strength, ductility, and shear strength, etc. And in effect, like the most of the pure metals, we can say, are relatively soft. If you take some iron piece and if you take a steel, and if you check the hardness, we can see that steel will be more than the pure iron. Okay, so we can say that the pure metals are mostly soft, and we will see how this internal stress increases the hardness. So few examples are like brass. Okay, it's of high strength than copper. The high speed steel, its hardness is very high in comparison to our ordinary iron. The stainless steel, it's having superior corrosion resistance in comparison to our ordinary steel as well as our iron. Okay, so now more details like into alloys. So these are some of the alloys which you may be well familiarized. So this is the bronze. First I will discuss about that one. The bronze is an alloy of a copper, as well as the brass is also an alloy of copper. So here the bronze is the alloy of copper and tin, and was the first alloy which was discovered. In the initial classes we discussed about the Bronze Age and all. During that period the bronze metal was identified. So such things were done in those days itself, even before the finding of our steel and iron. So it was harder than the copper and originally used to make tools and weapons, but was later suppressed by the metals and alloys with better properties, mainly by the iron and its alloys. After the invention of iron and its alloys, the bronze or the popularity of the bronze came down. And in the later years, okay, the bronze has been widely used to make the ornaments, like bronze ornaments, the bells which we see in the temples and church and all, the statues, various statues, and for the bearings and all. So brass is also another alloy which is widely used, and you can identify it from the figure itself. So it's basically an alloy of the copper and zinc. Okay, some advantages of these alloys is that it will make our metal, our parent metal, more harder. This alloying will make it more harder. So how it will make it harder? Okay, so this explanation is given here. They are made up of atoms of different sizes, as we have discussed earlier, rather being uniform. So uniform crystalline nature of a particular parent metal will be changed with the addition of atoms. This means that the layer of atoms cannot slide over each other easily. So that smooth sliding, okay, that smooth sliding will be interrupted, making the whole alloy much stronger than any of the pure metals, and that the alloy contains in isolation. Okay, so that extra or that new atoms which differs in the size, okay, that will make a particular hindrance to the smooth flow of these metals or the smooth lattice structure. So that smoothness will be inside smoothness will be disturbed. So what will happen is that it will restrict the sliding movements, crystalline sliding movements. Similarly, other properties like it will improve the tensile strength, it will reduce the melting point, and this particular thing we will see in in our in our coming slides, where we will discuss the phase diagram. And the metals, as we see, the stainless steel and all the metal alloys will be more resistant to corrosion. Okay, and it will also resist the chemical and other weather attack. So it improves the shear strength just like tensile strength, and it will also improves the ductility. So these are some of the alloys and their compositions which you can go through in the notes. I'm not spending much time. So these questions, such questions will be very important the gate aspect of view. So moreover, it will be also be asked in detail for various interviews and all. So better try to understand the names of these alloys. Okay, so you can expect some application level questions also from these areas, like some questions you can see this. If you see the syllabus, you can see some questions which is asked related to nichrome. Okay, for the exam questions they will just mention this name only, so don't be confused. Sometimes they will ask some sterling silver, and it's some kind of applications in any particular area, and then you might be able to understand that the sterling silver is formed by a alloy of some silver and some copper and okay. So you must understand that concept. So for that you need to read this particular thing, as well as the read the textbook in detail. Okay, so next is the classification of the alloys. The alloys are widely classified into two types. That is, first one is solid solution alloys and the intermetallic compounds. Solid solution alloys are further classified into substitutional and interstitial, and the intermetallic compounds are further classified into electron and interstitial. From the name itself, I think you got some idea. And in the next video, we will deeply see this solid solution alloys in particular. So thank you for your attention, and see you in the next video.